What's going on, everyone? My name is Johnny Bandon, and I will be your instructor for this CCNA video series. In this CCNA series, we're going to be going over trunking in this section. So the first thing we're going to go over when we go over these sections that have a lot of CLI and lab time, hands-on keyboard, is of course we're going to hit the PowerPoint first, get our fundamentals, learn about the technology, and then the majority of this section going over trunking will be on the CLI. So stay tuned, and I hope you guys enjoy this video. All right, how's it going, everyone? Let's go ahead and begin our trunking lecture. So before we get into the actual bullet points and the slides, let's just recap what we learned about VLANs, right? So VLANs are a logical way to segment your LAN using what we call a VLAN ID. So that VLANs can span across multiple different switches. However, the problem we saw in our last VLAN lab is that when we had, let's say, VLAN 10 right here, VLAN 20, and VLAN 10 right here, is that we couldn't get access over to our buddy in VLAN 10 across this switch. Now, why was that? It's because the traffic coming across this link was not getting tagged with that VLAN 10, or it wasn't allowing tagged VLAN 10 traffic to come across the link. Because we left this one at our default, it was in VLAN 1. Now you may be asking, well, okay, easy fix. What if we just put this interface into VLAN 10 and this one into VLAN 10? Yes, then we would get connectivity. However, what happens to our guys in VLAN 20 then? Oh, just switch it back? Well, obviously we know this is not a scalable or a solution at all. So what is our solution? Something called trunking. We need to create a trunk port, and when we create that trunk port, using our encapsulation 802.1q standard, we are going to allow inter VLAN communication, meaning that trunk port is going to allow any VLAN tag to come across, okay? So let's go ahead and jump right into the lecture. So trunk overview. So again, trunking is the key to all inter VLAN communication. I like to think of the trunk as a big 6-lane highway that goes both ways, right? The VLANs are the cars that are going to travel on your highway, the highway being your trunk port. And then there's multiple different ways we build this road, or different encapsulation methods. And really we say that because this is a exam where we got to go over the fundamentals, but there's only one encapsulation method that you're ever going to see out in the real world, and that's 802.1q. However, there is a Cisco proprietary flavor of encapsulation called ISL that we have to talk about. We have to because it may be asked about on the test, but we're not going to configure it, and we're going to just learn the basics of it, as in it's Cisco proprietary. So there will be a slide, but the encapsulation method that you're going to see is 802.1q. And on newer switches, you don't even get the option to put a trunk using this encapsulation method. It's just automatically 802.1q. So it's just something to know. So I think the overall concept of a trunk is pretty easy to understand, right? You need to build trunk or configure trunk ports when you have switch-to-switch communication, and these switches have multiple VLANs, or when you're doing a switch to router, you also need a trunk port, because your VLANs need to have a default gateway, which is that layer 3 device, and all your VLANs are still going to come talk to this router, right? So you need a trunk to router as well, and that's why this image, I put a router on one side and a switch on the other side. So anytime you see a switch-to-switch connection, think trunk port, okay? Okay, and then of course the encapsulation standard, which we already went over, is 802.1q. This is the IEEE standard, non-proprietary. 802.1q, encapsulation technology. It's what we use when we configure inter-VLAN routing, router on a stick as well, which we'll get into later on in the series. And then I told you about the other one, the Cisco proprietary one, which is called Interswitch Link Frame Structure. Not gonna go into this frame. I mean, you can see already some, things about it. 26 bytes instead of the 4 bytes of 802.1q. It's not commonplace. I've never seen it used, and 802.1q is definitely the standard for trunking. Just important thing to know for your exam that this one is Cisco proprietary. So in a vendor neutral environment, as in you maybe have Juniper, Dell, Cisco switches all in one in enterprise, ISO is not even an option, right? You use 802.1q. Okay, now let's go over the configuration of trunk ports. So creating a trunk is very simple. However, because we're taking a Cisco exam, they want you to know the different ways you can form a trunk. Dynamically built trunks I hardly ever see in production environments, but we're going to learn about them. So to start off, make it simple, let's just go over a static trunk. What this means is that when we build that trunk, we get into our interface. That's the interface connecting us to the neighbor switch or neighbor router. And we're going to have to define what encapsulation we're using first. This is chronological, okay? And like I said, this is going to depend on your iOS, but if we don't put this command in first, defining the encapsulation method on at least the lab environment switches we're using, it's not going to allow us to even put this command here, switch from mode trunk. We need to define the encapsulation standard we're using, .1q, 802.1q, and then we can say, all right, switch port, your mode is going to be trunk, and that's a statically built trunk. And then we have dynamically built trunks. What this is a protocol called the dynamic trunking protocol. Let me write this up here. Dynamic trunking protocol. And what this does is send negotiation messages via the native VLAN, right? And CDP, Cisco Discovery Protocol. And it's going to try to auto-negotiate our trunks, okay? So it has two different modes. One mode is desirable, and one mode is auto. When we configure our switch port to be switch port mode dynamic desirable, it's going to actively negotiate. When we put our switch port in mode dynamic auto, it's not going to actively try to negotiate with the other side, but it will be able to receive negotiations and form that trunk or even an access port, right? Because this is negotiation. So this could negotiate an access port. In the next slide, I'm going to show you the chart on how trunks form using DTP. Now, here's something that messes up my students a lot that I'm going to try to explain to the best of my ability. Does building a static trunk turn off the DTP messages getting sent? It doesn't. Even with a static trunk, where we say the mode is going to be trunk, negotiation isn't going to happen, but the DTP messages on the wire are still going to get sent. And I'm actually going to show you that in Wireshark. You may say, well, that doesn't make a lot of sense, but it will when we do that Wireshark capture. So the actual way we turn off all DTP messages is with this command down here, which is switch port no negotiate. Okay, now let's go over verification. So the one command you got to know about to verify your trunks is show interfaces trunk. This is going to bring out an output that shows you what ports have formed a trunk, what mode they're in, right? Or how they formed actually. So with on, that means it was a static trunk. What encapsulation the trunk is using, and then the status of it. So it is trunking. And then it also shows you the native VLAN. So why is it showing you that on the trunk when the native VLAN, which is VLAN 1, the default could be on all of our access ports too if we didn't do configuration? Well, that's because if we ever want to change the native VLAN for our switch, like the whole switch, we do that via our trunk port. And I'm going to go over that with you in our second lab. And then down here, we also see some more information. VLAN's allowed on the trunk. VLAN's allowed and active in our domain. So what does this mean? Well, since we see VLANs allowed on a trunk, it's safe to assume that we have a way to filter which VLANs can come across the trunk, meaning we can filter and administratively allow only certain VLAN ID tagged frames across that trunk. And we're also going to go over that in the next slide and in our labs. And then this command right here, show interfaces, and then the gig 30 switch port. This is going to give us a lot of information on the operational and administrative mode. So we can see the switch port is enabled, which means it's layer 2. We can see that administratively it's trunking. Operationally it's trunking. And the difference is that someone set this, and this is what's actually happening on the wire. And then we can see administratively someone set it to .1Q, and that's what's actually happening on the wire. And then we also see that DTP is turned on. That's what this output means here, negotiation of trunking on. And I'm going to show you that even when we configure a static trunk like this, if we execute this command, negotiation of trunking still on even when we set up a static trunk. And that's the importance of this command down here, switch port no negotiate. Okay, and then I told you I was going to show you that chart. So a couple things. DTP is a layer 2 control protocol. DTP uses the native VLAN to carry the negotiation messages. And if we leave DTP on, it can be manipulated by threat actors to perform a VLAN hopping attack, which is one of the reasons why even when we form that static trunk, we have to turn negotiation off because we don't want that to be available. And then you can see here this chart. If one switch is auto and one is auto, it's just going to form an access port. It's not going to form a trunk. If both sides are desirable, it's going to form a trunk. If one side's desirable and one side's auto, it's going to form a trunk. So go ahead and take a pretty good look at this chart, guys. It's very important for your exam and for real world. More than likely the exams we're going to want this knowledge, but desirable but desirable, you're going to form a trunk. Desirable auto, you're going to form a trunk. If they're both auto, no trunk, you have an access port. Okay, and then it should be the last thing we go over is VLAN or trunk pruning. So sometimes you may want to deny specific VLANs from parts of your network. Or you just need to practice good security, right? If you have a black hole VLAN, maybe you don't want that black hole VLAN coming across your trunk because you want to give the person plugged into that switch port no access to the internet or your network resources. So how do we do that? Well, at the trunk port, we can execute this command, switch port trunk allowed VLAN. Then we can give a list of VLANs. And then we can add to that list, remove from that list. We can do a range. And we have this command here called accept, which means allow all VLANs except 888, which is what I always choose as my black hole VLAN. All right, I'm going to get into this a little bit more because I'm going to show you a common mistake administrators do with trunk pruning when, let's say they missed a VLAN they wanted to allow. So they just type in this command again with the VLAN they missed. So let's say they just typed in VLAN 40. And what this does is take over from the previous command. So you just got rid of that list you put on prior. I'm going to show you that in the lab as well. So, all right, so that's going to be it for this trunking lecture. Stay tuned for our lab videos. We're going to go over a basic trunking lab and then a little bit more complex trunking lab. So thank you guys for viewing.